it is its equation is y is equal to fx, and suppose at a point we have to check that it is whether it is differentiable at this point or not. This we have to check at this point. X, let's suppose this is x. When we go ahead, we will take small increment x plus h. Here, suppose this will be x plus h, and before that it will be x minus h. So a small increment has given. So we will go ahead x plus h, and yeah, don't need to check x minus h, not required here, because we are going to prove fx plus h minus fx. So this is the increment given. Then there is a line, we can make some more distance between them so that it becomes easy to understand. That's why. Otherwise, it is a very, very small distance h. Okay, I'll try to make you understand that this is P point, this is point P. This is Q point, and a line passing through P and Q. This is passing through P and Q. Secant. This is a secant. Okay. This is not a tangent at this point. So this line can be extended. Here it can be extended up to here. I mean to say that this is a line and this is a curve. And this is P point, this is Q point, and on x-axis this is x, and this is x plus h. So when you see this on this side, here it will be fx, this will be fx at x, value of fx at x, and similarly at P point, this point on y-axis will be fx plus h. Why we are saying that dy by dx derivative? Yesterday we have seen d by dx of fx is equal to limit. In 11th also we have seen h tending to 0, fx plus h minus fx plus h minus fx divided by h. This is the derivative, and this is geometrically derivative of a function is the slope of a tangent at a point. Is the slope represented by the slope of a tangent at, we are taking at x. If it is some other point, we can take c or c plus h. Okay. Now what we have to see that actually, if we try to bring p near to q, if we try to bring p tending to q, correct? If this point p will become q, means will come towards q, that means h, this is what? This is the distance h. This distance is what? H distance. So that means, it means that h tending to 0. When p tending to q, whenever p will go out towards q, the h will tend to 0, correct? One thing, the limit according to this limit. So this is, then what is the tangent of this one? This if p will go to this point q, then at q, when p will become q, then there will be a tangent at this point. We get what? We get the tangent at this point. Let me show this. This is the, when p will go to q, then there will be a tangent at this point, correct? And this tangent is making an angle with the x-axis, and its slope. Its slope will be the derivative at this point. So how? Its slope, we will find the slope. So slope, what is the formula of slope? If you remember, m is equal to, if a line is passing through 2 points, its slope is y2 minus y1 upon x2 minus x1. And this point, what are the coordinates of this point? P has coordinates x plus h, x-axis, and fx plus h. And the coordinates of point Q are x and fx. Correct? Now, if we find the slope of this line PQ, slope of PQ, then slope will be y2 minus y1. That means fx plus h minus fx on x2. What is x2? X plus h minus x. So x and x will cancel. We get fx plus h minus fx. And this slope will become the slope of a tangent. This is the slope of this secant. Slope of PQ means secant. This is called secant. It is cutting at 2 points. So this is called secant. So when it will become a tangent? When h tending to 0. If we take the h tending to 0 means P will become Q, then h tending to 0. So we can say that the slope of tangent. Are you understanding it? Slope of tangent. This is the geometrical interpretation of differentiation. This is what geometrical geometrical of interpretation of derivative Geometrically, derivative is the tangent at that point. So then the slope of the tangent at Q will be equal to limit h tending to 0, limit h tending to 0, fx plus h minus fx upon h. Okay, got it? And this is the slope of a tangent. This is also the slope of a tangent. That's why this derivative represents the slope of a tangent. This is the meaning of this one. Okay. And from this only, so this is the definition. If you want to find derivative of any number, what we will use, we can say that derivative of function d by dx, it can be written as d by dx or f dash x. We have done in class 11 actually this. So dy dx of fx will be equal to what in terms of limit? That is called the first principle, finding the differentiation by first principle, fx plus h minus fx upon h. And we have seen this dy dx of sine x we have done in class 11. I'm not going to do with the first principle, just I'm just telling you the formula that we have done. What was the differential of sine x? Cos x. So like that, you whatever you have done in class 11 differentiation, cos x is equal to minus sine x. Like this, you have to remember all these formulas. D by dx of x to the power n nx n minus 1, d by dx of log x 1 by x, d by dx of e to the power x, e to the power x. These all formulas you have to remember. There is a list you can see d by dx of 10x. If 10x is equal to sec square x, okay, you can remember. So then what will be the differential of cot x? Cot x will be minus cot x will be minus cosec square x. Okay. Similarly, d by dx of sec x is equal to sec x 10x, and then differential of cos sec x will be equal to cos sec x cot x. cosec x minus cosec x cot x. So these are some standard formulas that cosec x cot x that you have done in class 11. Now our problem is, suppose I will take, now we are going to do the T substitution. T substitution, that is called chain reaction, chain rule or T substitution. Chain rule or T substitution. T substitution. Our problem comes, suppose if we have given the standard form, suppose y is a function, find dy by dx, you have to find the derivative, find derivative or find dy, find derivative of derivative. If the question is y is equal to sin x plus e to the power x minus x square, then we can easily differentiate both sides d by dx, and this will become dy by dx, right hand side dy by dx of sin x, and this all we have done product formula. This maybe if you have not done, you will see no problem. So e to the power x minus d by dx will go in addition and subtraction inside directly. So sin x, differential of sin x is cos x plus e to the power x is e to the power x, and x square is 2x, nx n minus 1. This formula, what formula is this? Nx n minus 1. But this is called, when we have standard form, we can say standard definition. But sometimes we have the composite function, means function inside the function. Sine, and inside sine you have e to the power x, let's say e to the power x. How will you differentiate these types of functions? So here we have to use T substitution. Okay. So what is the basic? Just try to understand basic. Afterwards we will do directly. So first we have to find the derivative. First we will write differentiate both sides with respect to x. Differentiate both sides with respect to x. Both sides with respect to x. Okay. So dy by dx. This is our aim. We have to find dy by dx. It is equal to d by dx of sine e to the power x. Now the problem comes that we cannot directly write sine e to the power x will not be equal to cos e to the power x. Yes. No, we cannot write directly. Just see that sine e to the power, any function inside the function, these are called composite function, cannot be equal to cos e to the power x. Okay. So in order to find this derivative, actually after explaining it chain rule, we can do directly also. Huh? So what we will do later on directly, but we should know first of all why directly is coming. So what we will do, we will substitute something so that it becomes the standard formula. If we put, okay, we can put e to the power x is equal to t. Put e to the power x is equal to t. After this, you will write put e to the power x is equal to t. So we get d by dx sin t. Okay, this will reduce to sin t. Sin t is the standard formula whose differentiation we know. But here the problem is t function. This is the function of t, and it cannot be differentiated with respect to x. The function of x only can be differentiated with respect to x. Means the variable should be same. So in order to overcome this problem, actually our basic is we have to multiply and divide by dt, and this dt will come here and dx will go there. So we can interchange these two values. Then we get d by dt of sin t into dt by dx. Correct? Only we have to change. Why we are changing now? You can see that this is the function of t. It can be differentiated with respect to t. Now this is the function of t, and it can be differentiated with respect to t. So d by dt of sin t is what? Cos t. But here we will write as it is dt by dx. So first differential means first step over here. First step, over we got the differential of the outermost function. Sine is the outermost, and in the inside there is a function e to the power x. There will be a function inside e to the power x also, and it can be like 4, 5 functions, no problem. So cos x into dt by dx. Now you will have to put again value of t. Put t is equal to e to the power x, because this is the function of x. We have to bring the answer in e to the power x. So this will become equal to cos e to the power x and d by dx of e to the power x. Now you can see that e to the power x is a function of x. It can be differentiated with respect to x. This is also x, this is also x. So differential of e to the power x is e to the power x. So we get the answer cos e to the power x into e to the power x. This is our answer. So what we have seen? We have seen that what is the differential of sine? Cos. Then what is the differential of e to the power x? E to the power x. So if we can multiply like this, we can directly write also the differential of any function. Suppose y is equal to sine, we have seen that inside the sine e to the power x, and inside also one more function is cos x. So you have to do 3 times t and p substitution, and it will go. This is called chain reaction. Chain rule, sorry. This is called chain rule. So in chain rule, we can, instead of substituting this t, yeah, okay, I'll take the same example. We can do like this also, but you should know actually there are very chance, so you are making mistakes in doing this. I know that. So d by dx, if I want to write directly, so what I can write directly? If you want to write directly without taking t substitution, but be careful, don't leave any function without differentiation. You have to choose the outermost function, that is sine. So there, what is the differential of sine? You will write cos. Inside, do not change anything inside that function. You will write e to the power x as it is, and then you will write d by dx of e to the power x, e to the power x. You can see that we have reached directly to this point. You can see that we have from here, from this point, you can see by writing this way, we have reached directly to this point without taking any t substitution. Okay. So then after this, it is very easy. Now we can differentiate e to the power x. So we get cos e to the power x into e to the power x. So whatever functions are there, you will go like this. I will take 3 functions now. If you have 3 functions, let's say, suppose you have a function inside the function inside the function. Okay, 3 functions in composite. Suppose you have, you should check that which is the outermost function. Okay. Yeah. Okay, I'll take same example. Then I will go to the other example. E to the power cos x. E to the power cos x. Now you have 3 functions. Sine, inside sine exponential function, inside exponential cos function, cos x. Okay. So there are 3 functions. So it will be solved by the differentiating these 3 functions. But how to differentiate? By chain rule? You will write differentiate with respect to x. This is your step should be differentiate with respect to x. Both sides also, right? So we get dy by dx, which is the outermost function, that is sine. So dy by dx. So first you have to write in the starting the differential of the outermost function directly. Sine x. What is the differential of sine x? Is cos. So cos, and do not change inside functions as it is. Sometimes students are directly writing sin x cos x. No, here you have inside function this. Then go inside next function is exponential. So you will write d by dx of e to the power cos x. Okay. Now similarly in chain, according to the chain rule, you will write the differential of e to the power x. Now second step. This is the second step. Now you have to use the chain rule in this part. Okay. So here the outermost function is e to the power x, And what is the differential of e to the power x? Differential of e to the power x is e to the power x. So you will write e to the power cos x, it's differential, and then go inside. Inside is what? What will you find inside? Cos x. So you will write d by dx of cos x. Okay. And then in the third step, you will write. So this is the starting. That's why I'm telling you these are the steps you should follow in the starting. Later on, you can do it directly. E to the power cos x, and differential of cos x is minus sin x. This is the answer, and this minus we should write in the starting. So we have the formula E also we can write in the starting, e to the power cos x into cos e to the power cos x into sin. I think you understood. So we have the first exercise based on this one only. Okay. So I'm taking some questions from exercise number 1. There we have many functions which are composite. Huh? Uh, I will take some questions together and I will discuss one by one. We can do it fast. So these are the questions which are given in our exercise. All are based on T substitution. Okay. So we will see different questions. Now, if you see this, I think this one you leave it because here we have to use numerator denominator formula. So this formula I will teach you. Then we can do it. Here also you have to use the product formula. Okay. So you know then you can do it because first you have to use product formula. We are going to do the composite function in which the functions inside the functions are there. For example, we can take anyone. Okay, fourth question. I'll take first fourth question, then come back to other questions. So here you have seen y is equal to c, and inside that 10. When you write, you will go like that only. First outermost you have to write, then 10, then under root x. So you can understand easily if you are writing like this. So sec is the outermost one. So when differentiating with respect to x, so differentiate with respect to x, we get dy by dx. Hmm. And what is the differential of sec x? Sec x is sec x 10x. So we will write sec x outermost. This we are writing the differential of this sec. Sec x 10x. Sec not x, inside is 10 under root x, sec 10 under root x, sec x 10x, 10 under root 10, 10 under root x, 10, 10 under root x. Okay, so you understanding? These all are the basic starting of your differential calculus, and this is how this is the differential of sec x 10x. Then we have to write inside. If you go inside, you will find 10 now. So you have to do the 10, and inside 10 you have root x. So you have to do the differential of 10 now. So sec x as it is, you will write sec 10 under root x, sec 10 under root x into 10, 10 under root x and 10x. What is the differential of 10x? Outermost is 10. So differential of 10x is sec square x. So sec square under root x, but x is under root x. Then differential of under root x. And you should remember the formula under root x, differential under root x, 1 by root 2. 1 by 2 root x. D by dx, d by dx of directly instead of using that formula x to the power n under root x, you can remember 1 by 2 root x. So differential of root x is 1 by 2 root x. So we get finally sec 10 under root x into 10 into 10, 10 under root x into sec square under root x, and tan x is 1 by 2 root x. So 2 root x will come. Okay. Sometimes in this question number 7, if you see question number 7, in question number 7, which is the outermost function, 2 under root cot x square, 2 under root cot x square. So whenever any constant is coming, we will take it out. So when we are going to do the differential of this function dy by dx is equal to 2, we can take out, and we have to differentiate under root cot x square. Someone write in the chat box who can understand that which is the outermost function, which will be the outermost here. Write in chat box fast. Which is the outermost function? Mudassir, Saad, Tasneem, anyone, Aryan. Outermost function. That means nobody is understanding, huh? Yes, think it. At least you are thinking, Mudassir. No, you don't unmute. You can write in the chat box. Which is the outermost? Just write down fast. Like here, if I will ask, you can write C, K, C, C. That's all. So similarly here, what you can write? Here you have three functions. How many functions are there? Root, square root. You can write square root or root, and then inside cot, then inside x square. So root. This is the root. Differential of any root. I told you differential of any root function is 1 by 2 root. So root is the outermost. Root is the outermost function here. So what is the differential of root? Root is 1 by 2 root. So this will become 1 by 2 root cot x square. Okay. So root is the outermost function. Then you have inside cot d by d is what you have written. When you write this function formula, whenever you are writing the question, what will you write first? Root. They're very easy. If you start writing this question, okay, just see this. This is very easy way I discovered here, that if question you are going to write, okay, we have given y is equal to 2 root. What is written first? Root. Then what will you write? Cot. Then what will you write? X square. Here what will you write first? C. Then what will you write? 10. Then what will you write? Root. So whatever you have written first, this is the first function. Inside that second function. Inside that third function. Similarly here we have written root. Root is also a function. Root x. I told you. Just remember root x is 1 by 2 root x. Okay. I think understood. Okay. So that is the way to find out which is the outermost function. Got it? So now cot x square. Now cot x square. We have cot x is the outermost function. This 2 and 2 you can cancel. 1 by under the root cot x square. Okay. Then what is the differential of cot x? Tan x is sec square cot x minus cosec square x. So cosec square x is x square, then differential of x square. You have to practice. Okay, x square is this minus we can write in the starting, and cosec square also we have to write cosec square x square in the numerator, and denominator root cot x square, and this x square will be equal to 2x. So this is the solution. Okay, understood? Got it? So it is very easy to understand, but don't do fifth and sixth question. If you know how to do the product and quotient formula, then you can go ahead. Otherwise, leave first, fifth and second they put wrong, because first we have to use the product formula and quotient formula. So leave this fifth and sixth. You can try all questions. So you can see I have written. If you will write this question, you will write sine first, then x square. So outermost cos a cos sine outside, sec outside here, cos outside, then root inside, root x, two functions. Here we have root cot x by three functions. Then tomorrow we will take other questions. Okay, that's all for today. We have no, no, okay.